Hello, in the question we have given a fire truck is emitting a 550 Hz signal. So let us call this emitted signal as F0, that is given to be 550 Hz. The frequency of the siren is observed to be 640 Hz. So the observed, so this is F0. So observed frequency, so let us call it as f prime, that is equal to 640 Hertz is given. So by a stationary detector. Now the detector is stationary, so we will see what it means. So if the outdoor temperature is 24 degrees, so T is equal to 24 degrees Celsius, the temperature. So how fast is the truck moving? So we have to find out the velocity of this truck. So velocity of source it will be, because now the truck is the source of this emitted sound waves. So then we have to find out the velocity of source, that is velocity or speed of truck. So now in order to do this, we will use the Doppler effect. So now according to the Doppler effect, we have this equation, that is f prime is equals to f naught times v plus or minus v o divided by v plus or minus v s, where this vo is the speed of the observer and vs is a speed of source, and this v, just v, is the speed of sound. Now we do not know the speed of sound, so let us first find out the speed of sound. V at temperature T is equal to 24 degrees Celsius. So at this temperature, the velocity of sound, let us write it. So V is equals to V naught square root of T divided by 273. So this is the formula to find out the speed of sound at any particular temperature T. So we will just plug the value. So it will be V is equals to V naught is always 331. So this V naught is 331 square root of this temperature. So this is 273 plus this 24. So I will write here 273 plus 24 degrees Celsius. So this temperature is always calculated in kelvins. So let us write it neatly. So this is 273 plus 24. It is not 40, sorry. This is 24 divided by 273. And now if we calculate from here, so this velocity will turn out to be 345.24 meters per second. So this is the speed which we will be using. So now let us recall our equation. F prime is equals to f naught. Now let us tell over here, so this v naught is 0, because it is mentioned that it is stationary detector. So detector is stationary, so the observer is stationary, we can say. So this is 0. Then vs we need to find out. Now vs is coming towards the observer, that is detector. So we will use here the minus sign. So this plus or minus, so minus sign we use when this detector, sorry, the source is approaching towards the observer. So here minus sign will be there. So F naught into V divided by V minus V source. So now let us plug the value. So after plugging the value we will get the answer. So it will be 640 is equals to 550 into 345.24 divided by 345.24 minus of Vs. So now calculating this, so this 550 divided by 64, this will turn out to be 1.16, and this we will take it to this side, so it will be 345.24 minus of Vs, that is equal to 345.24. And from here if we just open this bracket we will get the answer as 400.47 minus 1.16 Vs, that is equal to 345.24. so this if I take over here, so this will be 400.47 minus of 345.24. so this 1.16 Vs will come over here. So if I divide both the sides by 1.16, I will get this as equal to Vs. So from here if we calculate, so V source will be equal to 47.61 meter per second. So this is the speed of the truck. I hope you find the solution useful. Thank you.